Let's start by recording our given information. So the toboggan is initially moving 5 meters per second. Now meters per second is a velocity and it's in the forward direction. So velocity needs both a magnitude, which is the 5, and a direction, which they're saying is forward. Let's call forward the positive direction to keep track. Now that's my initial velocity. It decelerates, so in physics that means you're slowing down, but we generally just stick to positive or negative accelerations in physics. We don't use the word decelerate in general, but we are slowing down. We know we're slowing down because our velocity is positive and our acceleration is negative, and when they're opposing one another, that means you're slowing down. And he holds that acceleration for 10 seconds. So his acceleration is negative, so to the left, 0.40 meters per second squared. And this acceleration is constant for 10 seconds. And we want to know the toboggan's final velocity after 10 seconds. We're trying to figure out VF. Now we know the equation. Acceleration is change in velocity divided by time. Now change in velocity is always final minus initial. Change in anything in physics is V final minus V initial. So that's the top of your equation. The bottom, we're dividing it by time. So A equals V final minus V initial over T. And we want to get V final by itself. So we're going to do some algebra. Now when you do algebra, don't go inside the brackets till the very end. It's more efficient if you leave that variable inside the brackets and remove the brackets as your last step. Now, I'm talking about brackets. They're actually not drawn in here, but they're always implied to be on the top of your fraction. So the numerator, if there's more than one variable, is said to be in brackets. First thing I want to do is multiply both sides by t. T is divided on the right, so to get rid of it, if I multiply both sides by t, they cancel on the right. So convention has it that we put acceleration first. Don't ask me why. A times t equals V final minus V initial. Now I don't need the brackets, so I'm not even going to put them in anymore. To get rid of the V initial, I simply add a VO to both sides. So plus V initial plus V initial on the left, negative plus a positive are gone, and I get V final. I'm just going to reverse my equation now. V final equals V initial plus A times T. And now we just put in our values. The units all match. We've got meters per second squared, and seconds. So that's the first thing I always check to make sure all the units are consistent with one another. And then we go for it. V initial was 5, and it was a positive. My acceleration was negative. And my time, which is a scalar, was simply 10 seconds. Now when I work through the bottom, I'm going to drop the units now. I get 5.0 minus 0.4 times 10 is 4. There'd be 2 sig figs in that term as well. And 5.0 minus 4.0 is 1.0, and the units would be meters per second. And notice my answer is positive. So we interpret the positive as forward. So my final velocity is 1.0 meters per second forward. Now it doesn't hurt at this stage just to check your units, just to make sure your equation looks right. If you look here, we're adding meters per second to something else that's 2 terms multiplied by each other. Now you can only add terms that are like together. They all have to be the same units. So whatever this is should be in meters per second. Well, I've got meters per second squared times seconds. So this second on the top cancels with one of them on the bottom, and I'm left with meters per second. So it should be good.